So in this video, we're going to learn how to calculate or how to find the space and time complexity of a given code. I'm just using JavaScript as an example. You can take any programming language. So first of all, we have a function which is called sum of sequence, which do some calculation. It has a for loop, it returns something which looks like a variable. And then we have a function which is called inside this sum of sequence. And then we're just console logging that. Now you can run this code, you can get your output. That's okay. I'm not going to do that. I can do that. But the purpose of this video is to understand what is the time and space complexity, right? So let's go to the board so that we can understand it deeply, what's going on here. So we have this sum of sequence function which has this pair sum function. Now, this function calls this function. Now, sometimes when we do that, it looks like, let's say, this function has a time complexity of O of n, and this has O of n, and sometimes we do like we multiply it because it looks like, oh, because this function is calling this function inside it, so that must be the time complexity of this code, which is going to be O of n squared. But if you're doing this is actually wrong. The given code is not of n squared because we need to go deep. So here you can see that we have a for loop, right? So we have this sum variable, and inside for loop, this loop runs n times. So the space-time complexity, sorry, this time complexity of this code, this part of code is of n because we have one for loop which runs n times. But inside that, we have this pair sum, right? Let's see what the pair sum is. Pair sum is basically just taking two parameters and returning the sum of it. It has no recursive calls, it has no for loop, it has no while loop, it's not doing if else, it's just simple returning that. So the time complexity of this code is actually O of is, if you multiply by O of n, we'll get n. So the time complexity of this code is O of n. It's linear. This code is a linear representation. It will not increase with, let's say this is n, the complexity is here. So this code will not go crazy like that. It won't happen. It will go linearly. So this code is good. I'm not saying like the best code, but it's at least it's better than O of n. Sorry, O of n squared, right? This is O of n squared, and we have O of n. So this will take less time to execute. Now let's understand the space complexity of this code. This doesn't do any recursive call or anything, right? Similarly, here we just have for loop which gets destroyed after we have the sum value. We don't need to keep for loop in the memory. So the space complexity of this code is actually O of 1. So the time complexity of this code is O of n, and space complexity of this code is O of 1.